everyone, welcome back to Diksha Karnataka YouTube channel, and you are watching your favorite series Sankalp KCET 2026, and today is the time for the chapter Ray Optics and Optical Instrument for the KCET PYQs. So I am going to discuss the KCET PYQs starting from last year, that is 2025, till we exhaust 30 questions. So 30 questions we are going to discuss in this lecture, so don't go anywhere. Please wait till all the questions are done, because all the questions are very important, and this is a very high weightage chapter from where you can expect at least 5 to 6 questions every year. So this is a very high weightage chapter, so you have to check everything, all the questions, all the PYQs. There are some patterns as well, and the questions are not too difficult. If you have gone through my lectures, if you have checked my lecture videos, then definitely you will be able to solve this. If you have not watched my lecture videos, then you please go and check them out, and then you can watch this KCET PYQs video. I hope everyone has seen that, and those who have followed my instruction last year, they are here. As you can see, their ranks are reflecting that they have followed not only me, all the other teachers' instructions as well, and they studied from us from the YouTube channel, and they have achieved a beautiful rank that you can see here. Maybe next year it is your turn, your picture, your name will be showcased here if you are following all other teachers, including me. Everything that we are saying, if you follow them, definitely you will achieve this leaderboard ranking, and you will be here as well. Now let's start with the first question of the day. So this is from KCET 2025. A ray of light passes from vacuum into a medium of refractive index n. So refractive index of the medium is given n. If the angle of incidence is twice the angle of refraction, then the angle of incidence in terms of refractive index is. So it is given that the ray of light is traveling from first medium is vacuum. So here it is basically refractive index is 1, and it is traveling to another medium of refractive index n, and it is incident at an angle I, and it is getting refracted to some angle r, obviously. Right now we have to find the angle of incidence in terms of refractive index, but it is also given that I is twice that of the r, right? So basically it is given that r is basically I by 2, right? Incident angle is twice that of refractive angle of refraction, so r is basically I by 2. So we know that from Snell's law, sin I by sin r equals to the refractive index n, because it's an absolute refractive index, right? Because it is coming from vacuum to the medium. So from here we can write sin I by sin I by 2 equals to n, right? Now what we have to be careful here is that in the differentiation we in the division we have I by 2. So how can we adjust this? In the numerator we have I, in the division we have I by 2. So what we have to do, we have to write sin I as 2 into sin I by 2 and apply the formula of sin 2 theta. Okay. So if we apply the formula for sin 2 theta, we know that it is equals to 2 sin theta into cos theta, right? So divided by sin I by 2. So sin I by 2 gets cancelled. Now what is on the right hand side? Right hand side is n, right? So this is equals to n. So from here we can write cos I by 2 equals to n by 2, or I by 2 equals to cos inverse n by 2. So what is the value of I? So value of I from here we can write I equals to 2 into cos inverse n by 2, right? So it will be 2 into cos inverse n by 2. So option A is correct in this particular question. Okay, no shortcut, everything is mathematics, and it is very simple mathematics. Only trick is you have to divide this angle and write this like 2 into I by 2. So this is a very old trick of the book. So if you know that, you can solve this. Now this is a common question. I have discussed this in my lecture. Write the division or division of lenses. A convex lens has a power P. It is cut into 2 halves along its principal axis. Further, one piece out of the 2 halves is cut into 2 halves perpendicular to the principal axis as shown in the figure. Choose the incorrect option for the reported lens pieces. Okay, so first of all, let us understand what is happening over here. So here we have one lens. First it is cut like this, 2 halves. Now this half is again cut into 2 parts. Okay, now if you have followed my lecture, I told you when you cut a lens, okay, if you cut a lens of focal length say f, if you cut a lens of focal length f from the middle, the focal length remains unchanged, right? Focal length remains unchanged. And when you cut it along the axis of the lens, the focal length gets doubled, right? The focal length gets doubled. So what is everything in this option are given in terms of power, right? So what is the power of L2 and L3? They have same power, no doubt about it, right? Equal halves, so they have same power. What is the power? Power is basically, if the power of this lens say P, if the length of this power is P given in the question, then this will have a power of P by 2. This will also have a power of P by 2. Whereas this one will have a power exactly equals to P because its focal length is unchanged. So focal length unchanged means power is 1 by focal length. So that will remain unchanged. Whereas in this case it will be halved because focal length is getting doubled. So power will be halved, right? Clear? If you forget that power is given by 1 by focal length. So if focal length is getting doubled, power will be halved. As simple as that. So now let's see the options. You have to choose the incorrect option. For your convenience, I have highlighted and marked it. In the question paper, you have to do it yourself. They will not do the special highlighting or capitalization of the word. That you have to do yourself. Identify the incorrect option, not the correct option. So be careful, there are 3 correct options but only 1 incorrect option. Power of lens L3 is P by 2. So which one is L3? So if you see the picture carefully, you will see that this lens is L3, this is L2 and this is L1. Okay, so power of L3 is P by 2, it is a correct statement. Power of L1 is P, power of L1 is P, this is also correct. Power of L1 is P by 2, power of L1 is not P by 2, so this is an incorrect statement. Let's see the last statement. Power of L2 is P by 2, power of L2 is also P by 2. So only incorrect statement here is this one, power of L1 is P by 2, so option C is correct in this case. The image formed by an objective lens of a compound microscope. So compound microscope, objective lens, it is real and enlarged. Final image is virtual and enlarged obviously, but first image formed is, so the first image formed by the compound microscope is always real, enlarged and inverted, right? So here it will be real and enlarged, so correct option is option 1. Okay, option 1 is the correct answer. Now let's move on to the next question. If R and R1, okay, the R1 is written like this, okay, it is given in the question paper like this as well. R and R1 denotes the angles inside the prism. So they are basically denoting the refractive angles inside the prism. Having angle of prism 50 degrees, it is written like 500, sorry for this mistake, it will be 50 degrees. So let me give me a moment to correct that. It is 50 degrees, not 500, okay. So angle of prism is 50 degrees. Considering that during the interval of time from t equals to 0 to t equals to t, r varies with r equals to 10 degrees plus t square. During this time r1 will vary with time as. So very interesting question. Okay, so r is given by this formula. What will be the formula for r1? That is the basic question. Okay, so r formula is given, you have to find the formula for r1. Now we know that from the prism relationship that if you add these two angles, that is r plus r1, you will always get, does not matter how the r is varying, it will always get this equals to the angle of the prism. Okay, this relation is always true no matter what. Now r1 can be written as a minus r. Now value of a is given 50 degrees. So 50 degree minus 10 degree plus t square. So it will be 40 degrees minus t square. So this is a very simple question. Okay, students sometimes gets lost in the thought because they think, okay, this cannot be this easy question. It is actually easy question. KCET question paper, most of the questions are easy. Only the language is slightly tricky. If you figure out the language, then you can solve up to 80 to 90% questions without much difficulty. Now this is from KCET 2024. So as you can see, 4 questions came in 2025 directly, and there was 1 question from the optical instrument experiments. Those questions I will discuss separately in a separate video later on once the Sankalp series is over. Okay, not in this lecture. The final image formed by an astronomical telescope is real, erect and diminished, virtual, inverted and diminished, real, inverted and magnified, virtual, inverted and magnified. So final image, many cases whenever you are seeing inside a eyepiece, they are always virtual, no matter what device you are using, be it microscope, be it telescope, okay, be it binoculars. So whenever you are seeing it through a eyepiece, the image is always virtual, and main purpose of the device is to enlarge the size of the object, right? So it is always virtual, inverted and magnified. Okay, virtual, inverted and magnified. Magnification is the main purpose. Virtual image, whenever you are seeing through it an eyepiece, that means you don't need a screen. In case you are seeing it through a screen, for example, if you remember in the childhood, when you are a child, when you are studying in lower classes, you may have designed something called a pinhole camera, or maybe you have studied about pinhole camera. In pinhole cameras, the image is formed in a screen, so that was a real image. Okay, other than that, all the other optical instruments that you will use, whenever you are seeing it through an eyepiece, the final image is always virtual. Okay, if an angle of minimum deviation is equal to angle of prism for an equilateral prism, then the speed of light inside the prism is. So very interesting question. Angle of minimum deviation is equal to angle of prism. Minimum deviation is equals to angle of prism, and also it is an equilateral prism. Equilateral prism means any cross section if you take, it will be an equilateral triangle. So if it is an equilateral triangle, then angle of the prism, even though it does not look like a equilateral triangle, it looks like an isosceles triangle. So let me correct that. So if you take an equilateral triangle, then angle of the prism will be always 60 degrees. Okay, so angle of the prism will always be 60 degrees, so that means this is equals to 60 degrees. Now what is the relationship between refractive index and angle and delta? It is basically given by sine A plus delta by 2 divided by sine A by 2. So almost each and every year you will see a question which is from this concept. Angle minimum deviation 60 plus 60 by 2 by sine 60 by 2, that is sine 60 divided by sine 30. Sine 60 is root 3 by 2 and sine 30 is half. So sine 60 by sine 30 is basically root 3. Right, but this is not the question. The question they asked is what is the speed of the light in that particular medium. Okay, so they have punched another concept. What is that concept? That refractive index is basically given by C by V. Okay, refractive index is given by C by V. C is the speed of light in vacuum, V is the speed of light in that particular medium. So V we are trying to find, that will be C by N. Okay, so speed of light in any medium is given by C by N. C is 3 into 10 to the power of 8. That value is constant. We know that N value is root 3, right? We have calculated that. So you just need to rationalize it. So you will get root 3 into 10 to the power of 8. So correct answer is root 3 into 10 to the power of 8. Option C is correct. Next question, a luminous point object O is placed. So let's see the diagram as well. Okay, here is the luminous object. It is placed at some distance 2r. Okay, a luminous point object O is placed at a distance 2r from the spherical boundary separating two transparent media of refractive indices N1 and N2 as shown. So here it is N1 4 by 3, N2 3 by 2. So the values are given, the distance is given, okay, and the radius of curvature is r also given, okay, where r is the radius of curvature of the spherical surface. If N1 equals to 4 by 3, N2 equals to 3 by 2 and r equals to 10 centimeter, the image is obtained at a distance p equals to. So you have to find the image distance in this particular case. So you have to just put the formula and calculate it. What is the formula? If you remember, the formula is N2 by V, N2 by V minus N1 by U equals to N2 minus N1 by R. Everything comes with the sign. So always remember where is the image is forming. Image is forming behind this boundary in general. Okay, so image is forming behind this boundary means N2 by V minus N1 by U. U is here, right? U is given 2R over the, here, and R is given in this case. Now you have to find the sign. So as you know that in this case U is negative, V we are trying to find, N2 is given, what is the value of N2? N2 is given as 3 by 2. So N2 is 3 by 2 and so 3 by 2 by V minus N1 is 4 by 3, 4 by 3 into minus 2R. Okay, remember sign convention is still applicable here. U is in this side, left hand side, that means it is on the negative x axis, so U will be negative over here, right? N2 is 3 by 2 minus 4 by 3 and R is equals to R because R is on the right hand side, that means it is positive. Okay, as simple as that. Now let's simplify this. So 3 by 2V minus plus, right? So it will be 4 by 3 into 2R. So you can cancel this, and on this side you will get 3 to the 6, 3 to the 9 minus 4 to the 8 divided by R. Okay, so you will get 3 by 2V plus 2 by 3R equals to 1 by 6R. Okay, 1 by 6R. Now this will go to the other side. So 3 by 2V equals to 1 by 6R minus 2 by 3R. So it will be 6R 1 minus 4, so it will be minus 3 by 6R or minus 1 by 2R. Okay, so from here you can calculate the value of V. Don't worry about sign too much. Okay, sign you are applying the sign, so it will come out to be the correct answer. So 3 by 2V equals to minus 1 by 2R. Now do the cross multiplication, you will get V equals to 3R, minus 3R or plus 3R. Now let's see the answer. R value is 30 centimeter. So if you put the value of 30 centimeter, so you will get minus 30 centimeter. Minus means what? So minus means, what is the meaning of minus? Minus means the image is formed on the left hand side itself. So the final image after the refraction, whatever refraction happened, final image is virtual and it is formed on the left hand side itself. So it is forming 30 centimeter in the rarer medium, 30 centimeter in the rarer medium. Okay, 30 centimeter in the rarer medium. So this is the rarer medium, this is the denser medium. So if you see that this is 1.33, this is 1.5, right? So 1.33 is rarer than 1.5, so that's why the final image is formed on the left hand side and it is on the rarer medium. So 30 centimeter in the rarer medium is the correct answer for this case. This negative sign signifies this is on the left hand side, that is on the rarer medium. Okay, if you have any doubt, please mention that in the comment below. I will try to answer as much as possible. An equiconvex lens of radius of curvature 14 centimeter is made up of two different materials. Left and right half of vertical portion is made up of material of refractive index 1.5 and 1.2. So as you can see in the diagram, here we have two halves. One half is made up of 1.5 and this half is made up of 1.2, but radius of curvature for both sides are same, which is 14 centimeter. Okay, now the object is placed at a distance of 40 centimeter. Calculate the image distance. So they do not ask you about the power or focal length, they asked you to find the image distance. So this is slightly long question, even though the question is not super tricky. You have to apply the lens maker's formula twice and then find the focal length, and then you have to use the focal length to calculate the final image distance. That's it. So what is the lens maker's formula? Lens maker's formula is 1 by f equals to n minus 1 by r1 minus 1 by r2. Okay, so first we will find the focal length for 1.5. Okay, so what is about 1.5? So 1 by f 1.5. I am writing it like this. Now if you see that this is the lens, right? So this is the lens, means its radius of curvature on this side, right? So this is R1. So R1 is positive. And what about R2? R2 you can consider this as R2, which is for a single straight line. For a single straight line, the radius of curvature is infinity, because it's a plane. Plane can be considered to be a part of a circle whose radius is infinite. That is the definition of modern definition of straight line, right? So from this we can write 1 by f1 equals to what is the refractive index 1.5 minus 1 by 14 centimeter is given here, radius of curvature 14 centimeter is given, minus 1 by infinity. Okay, so this one is 1 by infinity. Now let's put the value 0.5 into 1 by 14, that is 1 by 28. So 1 by f1.5 is 28, so f1.5 is 28 centimeter. Okay, so you got the focal length for the first lens. Now what is the focal length for the second lens? We will use the same formula, 1 by f 1.2, 1 by f 1.2, that is the left lens, for you right lens, right? If you look into this like this, it is right lens, and if you look like this, it is a left lens, right? So now what is the radius of curvature for this? R1. Now for this lens, R1 is this one, this line. So again R1 is infinity, R2 is minus 14. R2 is on the left hand side, it is minus 14. So now let's put the values. Be careful while adding the values, especially for plus and minus. So 1.2 minus 1, 1.2 minus 1, and here it will be 1 by infinity minus 1 by minus 14. Okay, so it will be 0.2 into 1 by 14, minus will be plus, 1 by infinity is 0, right. So here you will go, this will be 1 by 70. Okay, if you multiply this, you will get 1 by 70. Now, how did I do it? So 0.2 by 14. So this is the calculation trick that I am going to teach you. In such divisions or multiplication, how you can do it quickly. So first you have to remove the decimals, and if you remove the decimals, you have to put a 0 over here. So it is basically 2 by 140, 2 by 140 can be cancelled as 1 by 70. So this is a mastery that I have acquired through a lot of practice. You also can do that if you stop using calculators for every 1 plus 2 is equal to 3 calculations. If you start using your head, if you stop using your calculator for every small calculations, then you can develop this skill as well. Okay. So now we have to find the combined focal length. We have to find the combined focal length. Here we have two convex lenses kept in contact. So combined focal length is basically f1.2 into f1.5 divided by f1.2 plus f1.5. Okay, this is how you do it. Or if you remember that 1 by f equals to 1 by f1 plus 1 by f2, which is similar to that of the parallel combination of resistors. So that's from that knowledge I have used this formula. So if you don't think that this is a new formula, I discussed this in the class as well. Okay, so this is the formula and this is how you use it as a shortcut. Okay, so it will be 70 into 28 divided by 70 plus 28. Okay, so it will be 70 into 28 divided by 98. Okay, now 98 is basically 49 into 2. 98 is 49 into 2. So let me cancel it, 35 by 49. So 4 7s are 28 and 7 5s are 35. So this is basically 5 4s are 20. So the combined focal length is 20 centimeter. Now your most of the task is done. So combined focal length is 20 centimeter, because if you read the question back again, you will see that the object is placed at a distance of 40 centimeter. So if you see the focal length, this is 20 centimeter. So object distance is 40 centimeter. That means it is equals to twice of the combined focal length. So when an object is placed at 2f, where are we expecting the image? Image will also form at 2f on the other side, right? So because the object is the distance is given as 40 centimeter, final distance will also be 40 centimeter. Okay, so this is how you can even you can guess the answer if you are smart without solving it, but if you are not smart like me, you have to do the mathematics and from there you have to deduce the answer, right? So even though the calculation part was a little long, final calculation you did not need to do because that is obvious from that question. Now let's see this question. A point object is moving at a constant speed of 1 meter per second along the principal axis of a convex lens of focal length 10 centimeter. The speed of the image is also 1 meter per second when the object is at dash centimeter from the optic center of the lens. So speed of the object and speed of the image are same. So speed of the object and speed of the image is same only when they are kept at a distance of 2f. Okay, when the object and image distance both are same, when the object and image distance both are same, okay, so if both are at 2f distance, then only the speed can be equal, because distances has to be equal for the speed to be equal. Okay, so if these distances are equal, then only it will move with the constant speed. Now focal length of the lens is given 10 centimeter, so the object must be at 20 centimeter, image will also be at 20 centimeter, so correct answer is 20. Okay, next question. For a given pair of transparent media, the critical angle for which color is maximum? Okay, so critical angle. So we know that light has to travel from denser to rarer medium, and sine critical angle IC, sine IC is given by 1 by n. It is the refractive index, relative refractive index of the medium. Right. So from here we can say that IC basically proportional to 1 by n. Okay, because if 1 by n increases, sine IC increases. Sine IC increases means IC value increases. IC for 0, obviously sine 0 is 0 and sine 90 is 1. So for that means if the sine theta is increasing, then this value has to increase. So that's why it is a directly proportional relation. Right. Now what else? We also know that refractive index is inversely proportional to wavelength of the light. Okay, if you followed my lecture, there I have discussed. So this is inversely, this is also inversely. So enemy of my enemy is my friend. So critical angle is directly proportional to the wavelength lambda. So whoever has the highest wavelength, they will have the maximum critical angle. So red light has the highest lambda, so red light will definitely have the highest critical angle, right? So which one will have the minimum critical angle from this given option? Mention that in the comment below. Which one will have the minimum critical angle? Mention question number 10 and then answer it. Okay, for minimum, question 10, for minimum color will be this. Okay, you can mention the color name or the option as well. Now, next question, for a point object, which of the following always produces virtual image in air? Okay, so which of the following, this question also I have discussed in my lecture, right? So if you are following my lectures, okay, I have discussed almost all the questions theoretically during my lecture. So only two things that can always produce virtual images. Okay, either it will be a concave lens or it will be a convex mirror. Let's see what is given here. Concave lens is not given, only convex mirror is given. So we will choose convex mirror. So this is the correct answer for this question. An equiconvex lens made of glass of refractive index 3/2 has focal length f in air. It is completely immersed in water of refractive index 4/3. The percentage change in the focal length is. Okay, so focal length is basically given by n minus 1 by r1 minus 1 by r2. So when it is in air, okay, what is the focal length? So 1 by f in air, it is given by 3/2 minus 1, okay, and say this value, I am not writing this value say equals to x. This will be constant. Okay, I don't want to write this constant every time, so I am saying this constant is equals to x. So I am writing this as x. Okay, so 3/2 into x, that is half x. Okay, now what is the focal length in water? In water, it will be a relative refractive index of the material of the glass divided by refractive index of the surrounding minus 1 into the same value x, right? So let's calculate this. It will be 9/8 minus 1 into x, so it will be 1/8 into x. Okay, so now what is the ratio of or they have not asked ratio, they have asked the percentage change in the focal length. Okay, so before finding the percentage change, if you see this will be 4 into 1/4 into half x, right? So from here, what is half x? Half x is 1/fa. So 1/4 into 1/fa. So from here we can see that f water is basically 4fa. Just invert everything, take inverse of both the side. So you get that the focal length is increased by 4 times, but they have asked you the percentage change. Percentage change means what? Change means initial final value minus initial value divided by the initial value into 100. This is the percentage change. This is how we calculate the change. So that is basically 4A FA minus FA by FA into 100 or 300%. Okay, 4 minus 1 is 3 divided by FA will cancel anyway. So 3 into 100% is 300%. So 300% increase, 300% increase because it is increasing, right? It has quadrupled, right? So 300% increase. Consider a glass slab which is silvered at one side and the other side is transparent. Okay, given the refractive index of the glass slab to be 1.5, if a ray of light is incident at an angle of 45 degrees on the transparent side, the deviation of the ray of light from its initial path when it comes out of the slab is. So here I have discussed this question. Here we have a glass slab and one side is silvered. Silvered means this is acting as a thick mirror. Silvered means this is acting as a thick mirror. Okay, so the generally the mirrors that we use is very thin, but this one is a thick mirror. So when the light enters into it, how the light travels? So the light initially bends, okay, it falls into this silvered side and then it gets reflected and then it comes out. Okay, this is how the everything works over here. Now what you can do is that you can just extrapolate that and you can say that okay, this surface is raised over here, so basically this is acting as a reflection, okay, but only the reflection is happening from this surface. So now we can use the reflection formula. When the light is falling over here, it is going over here. This is the angle of incidence, same as angle of reflection, and this is the angle of deviation. Angle of deviation delta is given by 180 degree minus 2i, right? This is the formula for angle of deviation. Now if you use little bit of geometry over here, you will notice that this is angle of incidence I and this everything is parallel over here. Okay, so if this angle is I, this angle will also be I. Okay, similar angle, and by the law of reflection this will also be I. So what is the angle of deviation over here? Angle of deviation is this angle, right? Same initial path and final path, angle between initial and final path. Intermediate paths does not matter, intermediate path does not matter. So it will be 180 degrees minus angle of incident is given over here as 45 degrees. So there will be 180 degrees minus 90 degrees, so that is 90 degrees. So 90 degree is the angle of deflection. Okay, now if you want to download the PDF of this lecture, then definitely you have to join our WhatsApp channel. The WhatsApp channel link is given in the description of this video. If you have not yet joined our WhatsApp channel, don't forget to join our WhatsApp channel. Also, if you have not yet subscribed to our YouTube channel, please don't forget to subscribe to our YouTube channel. Share this video with your friends so that our subscription increases and you get more better content every day. Right, focal length of a convex lens will be maximum for. So focal length, again it is basically the relationship between focal length and the refractive index. So if you remember, focal length is given by n minus 1 and 1 by r1 minus 1 by r2. So if you ignore this term is constant. If you for some time, if you, this is the minus 1 is also constant. So from there, if you ignore the minus 1 part for some time, then you can say that focal length is inversely proportional to refractive index. Right, f is inversely proportional to refractive index. Again, refractive index is inversely proportional to wavelength lambda. So friend of enemy of my enemy is my friend. So focal length is directly proportional to lambda. So whoever has highest wavelength will have the highest maximum focal length. So maximum focal length is for red light. Okay, maximum is for red light. This type of question is also very common, right? So relationship between focal length and wavelength. A ray of light passes through an equilateral glass prism in such a manner that the angle of incidence is equal to the angle of emergence, and each of this angle is equal to 3/4 of the angle of the prism. The angle of deviation is, so equilateral prism means what? A is equal to 60 degrees, right? We have already discussed it. And they also mentioned that angle of incidence is equals to angle of emergence. So I is equals to E, and angle of incidence is equals to angle of emergence means this is basically the case of minimum deviation. This is the case of minimum deviation, right? And this is, both of them are equals to 3/4 A. Okay, so 3/4 of A means, just calculate this, 3/4 of 60 degrees. So 15, so they are basically 45 degrees, 45 degrees. Okay, so this is the case for equilateral prism, and in this particular case, now what is the angle of deviation? Angle of deviation is 2I minus A, right? Both of them are equal. So this is the case for minimum deviation, 2I minus A. So 2 into 45 minus 60, that is 90 minus 60, that is equals to 30 degrees. So angle of deviation in this case is 30 degrees. Not difficult. A convex lens of focal length L is placed somewhere in between an object and a screen. Okay, convex lens of focal length L is placed somewhere between an object and a screen. The distance between the object and the screen is x. If the numerical value of the magnification produced by the lens is m, then the focal length of the lens is. So here we have a convex lens. Focal length is given by L, and the distance between the image and the object and the image is given by x. Okay, magnification is given by m, then focal length value you have to calculate. Okay, this L value you have to calculate. So this L value basically does not matter. Basically you have to find the focal length. So L, they have just given it for fun. Okay, so first, if this is u, this is v. Okay, then what we can write, u plus v must be equals to x, right? What else? V by u equals to m. Numerical value is given, so we will use without sign. So v equals to m into u. Now put this value over here. So u plus, this is, there is no sign required over here, right? Because this is just a simple addition. When we are adding applying in case of optical formulas, then only we have to use the sign. So u plus mu equals to x, or u equals to x by m plus 1. Okay, if you take u common from over here, I have just jumped one step. Okay, let me do that as well, because some students at some time they don't understand, sir, what you have done, I don't get it. So let me write this. Okay, so if you take u common, you get 1 plus m, or u equals to x by m plus 1. I have just inverted this. 1 plus m can be written as m plus 1, right? Now what will be the value of v now? So from here we can write v will be mx by m plus 1. Okay, it was mu, so u value we have calculated. So from there we can calculate the value of v. Okay, now again we have to use the length equation, 1 by v minus 1 by u equals to 1 by f. Okay, now u is negative, v is positive, so now you have to use the form sign. Okay, because we are assuming on the right hand side and it's a real image. Okay, because it is said that it is a image somewhere in the screen, right? So screen means it's a real image, right? Screen is mentioned over here. Screen means, so they have not directly mentioned that it's a real image, but they have mentioned it's a screen. So that means it's a real image. That means v is positive, u is negative. So v value we have to put mx by m plus 1 minus 1 by minus x by m plus 1 equals to 1 by f, or this minus minus cancel, so it becomes plus, so we get m plus 1 by mx plus m plus 1 by x equals to 1 by f, right. This m plus 1 will go up, so m plus 1 will be common. We get 1 by mx plus 1 by x equals to 1 by f, or m plus 1, even not only m plus 1, this x will also be common. Okay, this x will also be common. Okay, so let me write it over here only. Okay, m plus 1 by x is common. So if you do the thing, m cross multiply 1 plus m, right. So now 1 plus m can be written as m plus 1. This is equals to 1 by f. So m plus 1 and 1 plus m are same, so we can write this as m plus 1 whole square by mx equals to 1 by f. So from here we can write f equals to mx by m plus 1 whole square, right. So it will be mx by m plus 1 whole square. Option B is correct. So you have to just simplify it and solve it step by step and expect the answer. Next question, the power of an equiconcave lens is 4.5D and is made of a material of refractive index 1.6. The radii of curvature of the lens is. So power of equiconcave lens is minus 4.5D. So 1 by f equals to n minus 1 by r1 minus 1 by r2, right. This is the formula. Now power is basically 1 by f when f is in meters. So power is given here minus 4.5D, right. Now if you see, this is an equiconcave lens. So in case of concave lens, both R1 and R2 both are, so R1 is negative, not both, R1 is negative, R2 is positive. Okay, so R1 is negative, R2 is positive. Now we have to use that. So power P equals to, refractive index is given 1.6, right. Refractive index is given 1.6, so 1.6 minus 1 by r. Now equiconcave means both are equal, magnitude wise r1 equals to r2 equals to r. Okay, magnitude wise they are same. Okay, so minus 1 by r minus 1 by r. This minus is coming from here and this minus is coming from the fact that this is negative, r1 is negative. Okay, so power is given by minus 4.5 equals to 0.6 into minus 2 by r. Okay, both are minus, so minus will be common. So 1 by r plus 1 by r, that is 2 by r. So let's calculate the value of r from here. So minus minus cancels. So r equals to 2 into 0.6 divided by 4.5. Now remember, this is in meters. Okay, this formula is only valid when f is in meters, right. So this will be also in meters. So we have to convert it into centimeters by multiplying 100. Okay, but let's simplify this first. So decimal goes away, 3 2s are 6, 3 15s are 45. Okay, so we get this as r equals to 4 by 15 meters or 4 by 15 into 100 centimeter. Okay, so it will be 3 5s are 15, 3 20s are 100, sorry 5 20s are 100, so it will be 80 by 3. So 80 by 3 means 3 2s are 6, 3 2s are 6, 20, 3, 6, 18, another 20 by decimal, so it will be 26.6.6.6, and because it's an equiconcave lens, so focal radii of curvature can be positive, can be negative, but they have not mentioned, so only one correct answer is given over here, minus 26.6. But if it is on the R2, then it will be positive. If it is a R1, then it will be negative. So this is, there is one small mistake in this question, that they have not mentioned which R they are calculating, or what they should have given is the magnitude of the radius of curvature, not the negative sign. Okay, so this negative sign we can calculate it, as there is only one negative sign, so this is clearly answerable. Otherwise, if minus and plus both are given, then you could not differentiate whether they are asking you R1 or R2, both should have been correct. Okay, but here in this case only one correct answer is given, that's why there was no controversy regarding this question. If the refractive index from air to glass is 3/2 and that from air to water is 4/3, then the ratio of focal length of glass lens in water and in air is. So we have solved one question such as that. So if air is 3/2 minus 1 into x, x is 1 by r1 minus 1 by r2. Okay, so that previous case also we have written it like x, so in this case also I am writing this as x. Okay, so it will be x by 2. Okay, 3/2 minus 1 is half, and 1 by f water is given by 4/3 minus 1 into x, so that will be small mistake, it will be 3/2 by 4/3 minus 1, right. So it will be 9/8 minus 1 into x. Now 9/8 minus 1 means it will be 1/8 into x. Now they asked you what is the ratio of focal length water and in air, so you have to find the focal length of water by air. Okay, so if you see that what is the focal length in air, focal length in air is basically 2 by x. What is the focal length in water? Focal length in water is 8 by x. Okay, so just put the value 8 by x divided by 2 by x, x cancels, you get 4. So it will be 4:1. It will be 4:1. Not 1:4, but 4:1. So whenever there is a ratio based question, you have to be careful what is first, what is second. Okay, in ratio based question you have to be careful the order first and second, and based on that only you have to calculate. Generally there is a trap, both opposite for correct answer opposite fraction is also given. So as you can see, this 1:2, 2:1 both are opposite. Here 1:4, 4:1 they are also opposite. So you have to be careful and identify which one is correct. In refraction, light waves are bent on passing from one medium to the second medium, because the second medium, the frequency is different, the speed is different, the coefficient of elasticity is different, the amplitude is smaller. Now for light ray, when traveling from one medium to another, okay, light ray mainly bends because of the refractive index, and the refractive index we know is basically ratio of speed of light. Okay, so because the speed of light is different, the light ray bends. Frequency of light does not change on changing the medium, it remains same. Okay, so speed of light is different, that's why light rays bend when they enter into a particular medium. Two thin biconvex lenses have focal lengths f1 and f2. A third biconcave lens has a focal length of f3. If two biconvex lenses are in contact, the total power of the lenses is P1. If first convex lens is in contact with the third lens, the total power is P2. The second lens is in contact with the third lens, the total power is P3. Then which of the following is correct? So first of all, we have to use the formula that when two lenses are in contact, the equivalent focal length is given by 1 by f1 plus 1 by f2. Okay, now you have to remember that first lens is a convex lens, second is also a convex lens, third lens is a concave lens. Okay, so 1, 2 and 3. Okay, now focal length for this is positive and this is plus f1, this is also positive f2, this is negative f3. Okay, focal length for concave lenses are negative, okay, and focal lengths are given in this order. So when these two are in contact, what is the equivalent focal length? Now equivalent focal length I will not write it like this, because this is basically the combined power as well. Okay, so I, instead of writing 1 by f, I will write this as power P1. Okay, power P1 is basically when these two lenses are in contact, so 1 by f1 plus 1 by f2. So it will be f1 f2 f1 plus f2, simple, right? Now when 1 and 3 are in contact, that will give us power P2. So 1 and 3 is contact, that means it will be 1 by f1 minus 1 by f3. So the negative sign is coming from the fact that this focal length itself is negative, right? So it will be f1 f3 f3 minus f1. Okay, similarly we can write power P3. P3 is f3 minus f2 divided by f2 f3. Okay, because only f1 is changing, so if you just change, instead of f1 if you put f2, you will get the power 3. Now let us see the answer for this particular question. So P1 is plus, so P1 is plus in this case, P2 is minus, P3 is also minus, and everything is in the division, right? So from there we can say that option D is correct. In fact, if you are smart, if you find the power P1, you can easily answer that, because power P1 is given different, only one of the power P1 is correct. So from there you can say, okay, this is the correct answer. If you are smart, only after calculating this you can answer it, but for the sake of physics I solved the question completely. Now let us see the next question. The size of the image of an object which is at infinity as formed by a convex lens of focal length 30 centimeter is 2 centimeter. Okay. If a concave lens of focal length 20 centimeter is placed between the convex lens and the image at a distance of 26 centimeter from the lens, the new size of the image is. So let us see the question, and we have to draw the diagram as well. So object is at infinity. Okay, object is at infinity as formed by the convex lens. That means a parallel ray basically falling, a parallel ray is falling into a convex lens, and they are forming some image at some point. A very small point, it will be very small size, okay, and that focal length of this lens is given as 30 centimeter. Okay, and the image size is given as 2 centimeter. Okay, this convex lens is nothing, convex lens does not matter at all. Okay, if a concave lens of focal length 20 centimeter is placed between the convex lens and the image. So if you place a concave lens between this lens and this image, then what happens is that the image so you have to understand that the distance between the lens and the image is basically 30 centimeter, because when a parallel beam of light, when the object is at infinity, the image generally forms at the focus. Okay, it's highly diminished, but the size somehow is given 2 centimeter. Okay, even though this is very small, but for example, if you consider sun, the distance can be considered as infinity, but still the size can be measured, and suppose this size is 2 centimeter. Okay, it's like that particular case. Now if you put the concave lens, okay, the problem is this only. Okay, this is the only problem. You do not need to consider the convex lens at all, only its focal length is required. So a concave lens of focal length 20 centimeter is placed between the convex lens and the image at a distance 26 centimeter from the lens. So now we are placing this concave lens at a distance of 26 centimeter, right, from the convex lens. So what is the distance between this lens and the object? So now this will be acting as a virtual object for this concave lens, and they will form a image which is further away. Okay, so what is the distance? This distance will be 4 centimeter. Okay, this distance will be 4 centimeter. Now we will use the lens equation to find the final location of the image. Final location of the image, if we can calculate, we can calculate the magnification. So 1 by V minus 1 by U equals to 1 by F. Now interestingly, in this particular given case, U is positive. In this particular given case, U is positive because U is on the right hand side of this lens. Okay, so let me draw this particular case. Only for the concave lens is important. Convex lens is only giving the information that this distance is 30 centimeter. That's it. So some ray was going over here, but after falling on the lens, instead of going toward this will be moving somewhere further, and this will be our V. This is our U, this is our V. U and V both will be positive in this particular case. Okay. Now only thing we have to apply the lens equation and calculate it step by step. So 1 by V minus 1 by U equals to 1 by F. For concave lens, focal length is negative. So 1 by V equals to 1 by F plus 1 by U, or V equals to UF by U plus F. Okay, simple parallel combination lenses, parallel combination of resistors, simple concept that we have applied over here, right? Now put the values. So V equals to, U value is 4 centimeter. So 4 into minus 20. Okay, focal length for concave lens is negative, divided by 4 minus 20. Okay, this is again negative, so 4 minus 20. So this will be minus 80 divided by minus 16. Okay, so it will be 5 centimeter. Okay, it will be 5 centimeter. So what is the magnification? Magnification in this case is given by V by U, which is equals to 5 by 4. So what is the final size of the image? Final size of the image is basically the magnification times the original size. Okay, you have learned that. So it will be 5 by 4 into 2 centimeter. So 2 cancels and you get 2.5 centimeter. So concave lens is producing a magnified image, which is odd, but this can happen on this particular style of cases. Okay, so don't be surprised if you see, because this is not a normal case. U is positive over here, F is negative over here, and this is a very particular case, came in KCET 2021. This is, even though the question is easy, but this is a really tricky question if you have not practiced such questions. An object approaches a convergent lens from the left of the lens with a uniform speed of 5 meter per second and stopped at the focus. The image moves away from the lens with a non-uniform acceleration, moves towards the lens with a non-uniform acceleration, moves away from the lens with a uniform speed of 5 meter per second, moves away from the lens with a uniform acceleration. Let's see. So object, the lens is a convergent lens, focal length is not given, but it is given that the object was approaching the lens and suddenly it stopped at focus. Okay, so when the object is approaching, okay, I always give this example. Suppose you are walking towards the lens. Okay, when you are at a distance 2f, your image, exact same image will be formed at 2f. As you are approaching even further towards the lens, now an enlarged image is forming on the other side of the lens. It is further away from 2f. Now as you are approaching the focus, your image is going towards the infinity. Okay, as you are exactly at focus, your image is formed at infinity. Suddenly the object, before reaching f, the object was at finite distance, image was also at a finite distance, but as soon as you reach exactly at f, your image suddenly moves to the infinity. So the acceleration is basically non-uniform. Okay, and it is moving away from the lens, right? So moves away from the lens with a non-uniform acceleration, okay, or at an infinite speed. The speed of the image will be infinite at that particular point, which is very, very important. And the acceleration is obviously not uniform, because suddenly from finite to infinite, say from 10, suddenly it jumps to 1 lakh. So initially it is going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1 lakh. So definitely it is not an uniform acceleration. Acceleration is obviously non-uniform. Okay, so this is little conceptual in-depth question. If you know the concept, then you can answer this question. The refracting angle of a prism is A, and refractive index of the material of the prism is cot A by 2. The angle of minimum deviation is. So what is the angle of minimum deviation? Let's see. So refractive index is given as cot A by 2, right, and angle of prism is given A by 2. So from there also we know that for a particular prism, it is refractive index is given by sine A plus delta by 2 divided by sine A by 2, right. This is the formula we know. So we will put that same formula on this side, sine A plus delta by 2 divided by sine A by 2. And what is cot A by 2 means? Cot A by 2 means cos A by 2 divided by sine A by 2, right. So put that cos A by 2 sine A by 2. Obviously A is not 0, so A by 2 cannot be 0, so A by 2 can be cancelled. So from there we can write is that sine A plus delta by 2 equals to cos A by 2. Now one side is sine, one side is cos. How can we cancel that? For that we have to make both sides as sine. For that what we can do, we can say this is basically pi by 2 minus A by 2. So this is the identity. So we can convert a cos into sine by using this identity, sine 90 degree minus theta, right. Now sine cancels. We can say A plus delta by 2 equals to pi by 2 minus A by 2. Okay, by 2 all get cancelled. Now you get delta equals to pi minus 2a. Okay, so it will be 180 degree minus 2a. Pi means 180 degree obviously, right. So it will be 180 degrees minus 2a, right. This a will go to other side, so you will get 180 degree minus 2a. Now let's see this question. The following figure shows a beam of light converging at a point P. Okay, when a concave lens of focal length 16 centimeter is introduced at the path of the beam at a place shown in the dotted line. So you are placing a concave lens. Similar question. Okay, we have solved a similar question just few moments back. So here we have a concave lens. Okay, the distance is 12 centimeter and the focal length of the concave lens is 16 centimeter and it is negative. Okay, introduced in the path of the beam at a place shown by the dotted line such that OP becomes the axis of the lens. The beam converges at a distance x from the lens. The value of the x will be. So the beam converges at a distance x from the lens. So basically we have to find the v. Okay, final distance v we have to find. Simple formula, 1 by v minus 1 by u equals to 1 by f. Everything is given. And in this case, as I told you, in that particular case also the u is positive. So 1 by v minus 1 by 12 equals to 1 by the focal length is okay, let me use the simpler formula. Let me use the simpler formula, that will be easier. We don't need to do 1 by 1 by 1 by like that. So 1 by V, you can do this derivation every time if you want, or you just remember it and use it as you please. Okay, U by UF by U plus F. We generally when I was a student, I used to use this formula always. Okay, I don't used to do this derivation, this is very common. Okay, and for competitive examination anyway you don't need to do the derivation. If you remember it, it is very fine, very good. So V equals to U is 12 positive, focal length is given 16 centimeter, which is negative, divided by 12 minus 16. Okay, again the sign you have to use the sign, minus 12 into 16 divided by minus 4. 12 minus 16 is minus 4, minus minus cancels. Okay, 4 4s are 16, 4 12s are 48. So it will be 48 centimeter is the answer for this question. A certain prism is found to produce a minimum deviation of 38 degrees. It produces a deviation of 44 degrees when the angle of incidence is either 42 degrees or 62 degrees. What is the angle of incidence when the undergoing minimum deviation? Okay, so basically what we have to do, we have to use so this is a very interesting part. So either means what? Either means what is, if I is equal to 42, okay, then the emergent angle must be 62 or vice versa. Right, we have remember that graph of angle of deviation versus angle of incidence graph. This is the minimum angle of deviation. So minimum angle of deviation I becomes E, but for all other angle of incidence there is a particular set of angle of emergence. Right, if this is I, this must be E. If this is I, this will be E. Okay, this is the either or means. Okay, so 42 degree or 62 degree basically gives you this relation. Okay, and in this particular case the angle of deviation is given delta equals to 44 degrees. This is not delta mean, by the way, this is not the delta mean. So delta is given as A, sorry, not A, I plus E minus A. Right, for minimum deviation it becomes A plus I, sorry, 2I. So it becomes 42 plus 62 minus A. A value is not given. So first information we have to find the A. So A equals to, what is delta, by the way? Delta is 44 degrees. Okay, so if you add them you will get 104. Okay, 42 plus 62 is 104 minus 44. This is the value of delta. So 60 degrees. So angle of prism we have calculated. Now minimum deviation for delta mean 2I minus A. Right. So from this we can get 2I equals to delta mean plus A. Now delta mean value is given 38 and A value is given 60. So this will be 98, or I equals to 49 degrees. So the angle of incidence is 49 degrees, that is option A. Now next, a point object is, we have solved this question during my lecture, I am solving it once more if you have forgotten. Let's see the question. A point object is moving uniformly towards the pole of a concave mirror of focal length 25 centimeter along its axis as shown below. The speed of object is 1 meter per second. At t equals to 0, the distance of the object from the mirror is 50 centimeter. The average velocity of the image formed by the mirror between time t equals to 0 and t equals to 0.25. Okay. So now first of all let us understand, when the object started its journey, okay, the focal length of the mirror is 25. Okay, that means when the object started its journey, it was exactly at the radius of curvature, that is at a distance r. Right, this distance is basically radius of curvature r. So its image was also exactly at this position. The image was also exactly at this position, and it is moving with a speed of 1 meter per second. Okay, So 1 meter per second is the speed. So after 0.25 second, how much distance is moved by this object? After 0.25 second, how much distance the object moved after 0.25 second? That is our first objective. So the distance moved by the object, okay, after 0.25 second is given by speed of the object times the time. Speed of the object is 1 meter per second, that is 100 centimeter. Okay, 1 meter per second means 100 centimeter per second, right? So we are using that. Time is given 0.25, that is 25 centimeters. The object moved by a distance 25 centimeters. So 25 centimeter it has moved. So what is the distance of the object from the mirror? Distance of the object from the mirror is again 50 initial distance minus the distance moved by the object, that is 25 centimeter. So when the object is exactly at focus now, right? So when the object is exactly at focus, where the image will be formed? Image will be formed at infinity. Whenever the object is at focus, okay, for concave mirror or convex lens, the image will be formed at infinity. So when the image is formed at infinity, so what is the average velocity of the image? Average velocity of the image will be again infinity. Okay, so the average velocity of the image will be infinity. Okay, as the object, again as I said, object suddenly from finite distance is moved to infinity without just seconds, so that means it will be the final velocity will be infinity. You don't need to calculate it, you can do that, but it will be a waste of time. You have to identify it and then you can write it. An object is placed at a distance of 20 centimeter from the pole of a concave mirror of focal length 10 centimeter. The distance of the image formed is the question. So 20 centimeter is the concave mirror, focal length is 10 centimeters. So 1 by V plus 1 by U equals to 1 by F. Okay, so 1 by V plus 1 by minus 20. So as you have to remember that, oh, this is easier, we don't need to even calculate it. Okay, calculation is not required. Why calculation is not required? Because the distance is given 20 centimeter, focal length is given 10 centimeter. So that means the distance is basically equals to the radius of curvature. So image will be also formed at radius of curvature, but because it's a concave mirror, that means object is here, image will be formed at exactly at the radius of curvature, right? This is the condition, this is the case, and U is negative. U is negative, V is also negative. U, V both are negative. So the final answer is minus 20 centimeter, not plus 20 centimeter. So if distance is 20 centimeter, this will be, your image distance will be minus 20 centimeter if you consider the sign convention. A candle is placed 25 centimeter from a lens, forms an image on the screen placed 75 centimeter on the other side of the lens. The focal length and type of the lens should be. So candle placed in front of a lens and the image is on a screen placed 75 centimeter on the other side. So screen means definitely the image is real and only convex lens can produce real image. So first of all you have to find the focal length. Okay, 1 by V minus 1 by U equals to 1 by F. Okay, so UV by U minus V by UV equals to 1 by F, or F equals to UV by U minus V. Okay, just put the values. U is negative as per sign convention, so U is minus 25, V is on the other side, so that means it's positive, so minus 25 minus 75, you get this as minus 25 into 75 divided by minus 100. Okay, minus minus cancels, so let calculate. 5 5s are 25, 5 20 is 100, so it will be 4, so it will be 75 by 4, so it will be 1 35, 1 8 is 72. Okay, 32, 4 8 is 32, so it will be 18 point something. The answer will be 18 point something. So we have found the answer. It is positive because it's a convex lens, it will be positive, and the focal length will be 18 point something. You have to do mathematics because to find the exact value. During the scattering of light, the amount of scattering is inversely proportional to dash of the wavelength of the light. Now the scattering of light is not part of the syllabus, so I am skipping this question. A linear object of height 10 cm is kept in front of a concave mirror of radius of curvature 15 cm at a distance of 10 cm. The image formed is magnified and erect, magnified and inverted, diminished and erect, diminished and inverted. So this is an easy question. What is the mirror? Mirror is a concave mirror. What is the radius of curvature? Radius of curvature is 15 cm. That means what is the focal length? So focal length is half of the radius of curvature, that is 7.5. 7.5 means what is the object distance? Object distance is 20 cm. That means the image is basically a real image. It is the distance is greater than the focal length, so it will be a real image, real and magnified, because the image is between between f and 2f or f and r, so magnified, and it will be inverted. Real images are always inverted, so magnified and inverted is the answer. So magnified and inverted is the correct answer for this particular question. I hope you enjoyed today's session. I will be back with JEE PYQs very soon. Till then, bye.